Hi class, we talked already about the Big O theory and developing efficient algorithms. This video is to assist you in completing one of the exercises that's required for this chapter for you to turn in, and this is the one where you have to calculate the different prime numbers using the different algorithms and return an execution time. So I wanted to help you with that. In our first example in our textbook is the performance test, and we can use this performance test to gather statistics about runtime. So let's create this application. Let's see, I want a new project, and my new project is going to be, in this example, we're just going to add 5 to the number k, or to, the number in the variable k repeatedly to get some execution time information. So I'm going to name this performance test. And I'm going to get rid of the package name. Must already have that. Let's try giving it just a teeny bit different of a name. And as you remember from some of my other videos, sometimes my computer can be quite slow in saving to the local file system. And it finally is done. Now, I know it looked like it was a network file system. It's actually my local file system. It's a strange thing. Okay, for a performance test application, we're going to create a method called getTime, and I'm going to create that first. GetTime does not return any values, but it accepts a long integer that it's going to call n. And in our getTime method, we're going to create a long variable called startTime, and we're going to set that equal to the current time in milliseconds. Then we're going to initialize our loop variable k and set it to a value of 0. Then we're going to create a for loop. Now make sure you make this loop control variable I a long integer, not just an integer, or you're not going to get correct results out of your program. We want to execute while I is less than or equal to n, the number that was passed to us, and we're going to increment I. Now in this for loop, we're just going to add 5 to k. Then we're going to create another long integer to hold our end time and set that equal to our current time in milliseconds. Then we'll print out a message. Execution time for n equals we're going to take our end time and subtract our start time. to get our duration, and then add one more string, the word milliseconds. So in our get time, we establish a starting time, we initialize a variable k, and then we use a loop control variable I, and within our loop we add 5 to k for each iteration, and then after our loop is done, we grab the system time again so that we can calculate an elapsed time. In our main, we're going to call our get time module. So what we want to do is pass some different numbers to it. So the first time, we're going to tell it to add to k 1,000,000 times. 1, 2, 3, 1, 2, 3. Then 10 million. $100,000,000. $1 billion. And this will be our last one. And this one actually exceeds the limits of the Java runtime knowledge of a long integer. So it thinks that there's something wrong with this, so we actually have to specify to treat this as a long integer. Alright, let's run our program. And I see my output. And again, if you're not getting the last one, it could be because you didn't set your loop control variable in your for loop to be a long integer. Now, let's see, we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That looks right. So when you need to compare the beginning time to the ending time of an algorithm, which our textbook may ask you to do, this is an algorithm that you can use to control that. So you can embed whatever kind of code you need inside this loop so that instead of running k or doing whatever, you're doing something else. So let's take a look at one of the first things that you need to do. I'll go to the table of contents and find that exercise. Okay, there are lots of great programming exercises in this chapter. Please try some of them. 22.8 is your other one that we'll be looking at in a different video. And this is your other assignment, 22.14. So in 22.14, you're asked to use these listings that are in your textbook and embed them in this get time sort of logic, however you like to do it. You could have each of these set up as a separate class that you instantiate with a begin time and an end time. But you're going to run each of these with these different numbers of input to get prime numbers out and see what differences in execution time you get. So 22.5 is our least efficient prime number algorithm. 22.6 is more efficient, and 22.7 is the most efficient algorithm that uses the sieve of whatever your Stephanie's or whatever algorithm. So you're going to compare those different algorithms using different runtimes, so you know exactly what to do, because now you have the algorithm to do the get time. Now let's look at 22.5. The first of the algorithms for getting the prime number. So it will be in this section of finding algorithms for prime numbers. And we scroll down, and here is listing 22.5. So this is the one they're referring to. So I know that you could copy this code from Ravel. I would recommend that you not, just like in the earlier example. We went ahead and typed it in manually. Please type this code in yourself so that you're getting an understanding of what's going on. If you're not understanding what's going on with the code, please use the debugger in whatever tool that you're using to step through it, or send me a quick email so that we can talk about it. It's important that you understand how these algorithms are working, not just understand how to implement them. Okay, so this should get you started with that exercise. Like I said, let me know if you have any trouble, and I'll be getting with you on another video for the other exercise.